This is a next step, next generation software from KUKA Mobility. Um, Basically, the architecture of the system is set up that we have the mobile robot system, the KMReS. Has three parts to it: the workflow control system, the equipment control system, and the robot control system. Another subpart of this is the KUKA Studio. This package is used for commissioning the platforms, creating maps, setting up the parameters for the system. Okay, I think you can see my screen now. So setting up the parameters for the system and configuring the robot onto your wireless network. And then at the bottom of this, we have the KUKA. This is the operating system out on the vehicle platform itself. Our systems share a common operating system, and KMReS is able to control all of these. So moving forward, we're going to talk about the KUKA to start. As I said, KUKA is the operating system that runs on the platforms themselves. In North America, we currently have two platforms, the KMP 600 and the KMP 1500 platforms, and the KMP 3000 will be coming early this year. All of these systems run on KMReS. KUKA is divided up into three sections: the navigation model, the interface model, and the motion model. So the navigation model is the section of the software that does we do SLAM navigation, use the LiDAR. We do QR code navigation using QR codes, obviously. And then we have a hybrid navigation system, which allows you to use a mixture of QR codes and SLAM on this in the same system. SLAM is is it a system where the LiDAR and the odometry of the platform are taken together to localize the robot on a map. The map is a reference map from using the system to drive through your environment and gather all the monuments that would be within this environment. And then from that, we construct a reference map, and then we localize the vehicle platform to that map. And then we're using both the LiDAR and the odometry to properly localize it in this map. The QR code navigation, we use the SLAM map as our reference, and then you will place codes on the floor of the area, and the robot can navigate within the reference map using the QR codes. Why would we do this? This is perhaps you have a greenfield plant and you're adding more equipment and it's not currently there today, but it's going to be there, say, 6 months from now. So rather than generating a new map and going through all that exercise, you can choose to use QR codes, and the robot will navigate in your environment using the codes instead of the map. We can also use the QR codes for better accuracy when you're moving to a position. For instance, when you're moving to pick up a rack. The hybrid navigation is a combination of using SLAM and QR codes. So robot will continue to use the SLAM map as a reference, and then you can start to define zones where in this zone we're going to do SLAM, in this zone we're going to do QR. The switching is done automatically by the system as it's traveling through the zones. The KUKA Studio is the next system. We're going to start moving our way up the diagram. KUKA Studio is the next system. This is a commissioning tool that comes with the robot. We use this tool to create and manage our maps, our QR maps, our laser maps. We use this platform to localize our vehicles to the maps, to said maps. We can download these maps and edit them offline. We can synchronize these maps to KMReS. We can synchronize these maps to the vehicle. We can make copies of the map. And for instance, if we are in a multi-floor building and we have a similar layout on each floor, we can make a copy of the map and use one map for floor one and one map for floor two. And then as part of your management, you can also, delete maps, rename maps, and such. So now, moving up the next level, we're going to go into KMReS. This is the fleet management software. KMReS is divided up to, KMReS is our robot expert system. It is used for managing the vehicles. It is used for managing the containers that the vehicles are working with. It is comprised of three subsystems called Robot Control System, RCS, Workflow Control System, WCS, and Equipment Control System, ECS. Those three subsystems together are what constitute KMReS. So Workflow Control System, this is the subsystem that supports our integration, our creating our workflows, monitoring our real-time missions, being able to edit workflows, being able to monitor and those missions that are being executed used through the job board, being able to monitor and manage the containers that are being used in the system. The equipment control system, ECS, this is the subsystem that's talking to the external hardware. It can be used to talk to your appliances that you mount to the platform. It can be used to talk to external systems using TCP/IP, using HTTP, using MQTT, using OPC UA. You can then synchronize this communication with your workflow system so that you can trigger communication to external device from your workflow, and ECS will manage that communication and then trigger back to the workflow when that communication is completed in some manner. You can monitor the equipment that is connected and running. There are logs, there are live feeds of what's happening with the communication chain. We have the rule chain, which is where you can configure how you want these communications to occur and what protocols you want to use to do that. Again, we can do Modbus, we can do Ethernet IP, we can do OPC UA, MQTT. And then the third piece of the subsystem, the robot control system. This is the system that talks to the platforms, talks directly to KUKA through the wireless. It is responsible for the path planning of the vehicles. It does traffic control of the vehicles. We approach this as a no deadlock so that there's no two machines that are deadlocked on each other. So the system will manage that traffic and manage those deadlocks. Let's move on. And so RCS, again, we talk about map management, real-time monitoring, path planning, mission management, AMR management, rack management. All of this is part of the robot control system, RCS. We're able to talk to our platforms using UDP through your wireless network. There is also an option that is coming that will be able to control platforms using VDA 5050. The basic elements of this subsystem are graphing, being able to segregate your site into a warehouse, into floors and districts and maps, being able to manage the vehicles, the mobile robots, the containers and the container models, and being able to perform fine localization. And then finally, missions, being able to do the basic low-level missions like moving the vehicle, moving the lift up or down, being able to create special missions for charging, for resting, for carrying, we'll get an example of that later. The structure of the RCS is such that um, we have the bottom layer, which is doing the application, navigation, base control, motion control to the platform. We're doing UDP normally, and then we're able to interface up through and provide an UI to the working systems below. There's an interface to the WCS, there's an interface to ECS. And then we are able to use that ECS system to talk out to external equipment, doors, buttons, appliances, etc. Next, we're going to move into WCS, the workflow management system. So this is the higher level system where you can create workflows that can be executed and called from external systems to execute missions. From here, we'll have the ability to manage our workflows, create our workflows, edit our workflows, being able to view the jobs and missions that are running, being able to create events and create actions based on those events. Our workflow system, again, it's a set of tools that we can use to pull together. There's no programming on this system. It's all done through flowcharts. So you create these nodes of actions that you would tie together in the flowchart, and WCS will execute these workflows and provide from the workflows. You can provide triggers into ECS to trigger external equipment. You can wait on messages from external equipment in your WCS. You can interface to higher level systems, your MES, your warehouse management system. Um, uh, we can specify, when you specify a node, you're able to specify operational parameters like lift up, lift down, and you can include the destination, what actual node you want to travel to perform this action. You can do uh, pre-arrival commands, post-arrival commands, post-departure commands. These are actions or messages that will occur when you're arriving to a location or leaving a location. You can specify the angle that you want your container to travel between on the edges between the locations, and you can create waiting scenarios where you can dictate an area of the map that could be a queuing location when you're waiting for availability to go, for instance, pick up containers and move them to another part. Um, so events, these are the area of work, the WCS, where you're interfacing to the ECS at the lower level. You can trigger events down on the ECS level. You can wait for events to the event to return you some value from that. From the ECS level, WCS does monitor the system and is looking for when a container enters the system, when there's a completion of workflow, and provides information, and we can take that information and transfer it up to a higher level from WCS to your MES to your workflow warehouse management system. So from these events, you can trigger workflows, you can pause them, you can cancel them, you can resume them, you can queue them up, you can queue up multiple workflows, execution, depending on the number of vehicles in your system. You may have more missions than you have vehicles able to execute the missions. You can queue them up, and as a vehicle becomes free, it'll pull that mission from the queue and execute that mission. I want to go to the ECS now. ECS is the equipment control system. This is again where we are interfacing to external devices, appliances that you mount on top of the platforms, conveyors, lifts. It's where you can talk to external equipment, PLCs, using Modbus, using Ethernet IP, using OPC UA, and it's where you can monitor. This subsystem allows you to monitor these communication channels and what's going on with them. You'll get logs. There are logs available that will display information about the state of communications that are occurring. The ECS, excuse me, allows you to configure, depending on the protocol you're doing, the IPs, supports, protocols, etc. Common devices that ECS interfaces to are button boxes, automatic doors, conveyor lines, I/O controllers, traffic controllers, these kinds of things. We do, like it says, we do support multiple protocols. We support Modbus, HTTP, S7 for Siemens, MQTT, uh, OPC UA, and then ECS can be using rule chains, can be configured to process events and process triggers based on logic. You can create a rule chain that has a set of logic to it that you want to execute when that rule chain is triggered, and you can use that logic to create a response that you want to send to WCS from that rule chain while it's waiting for you to, if you've been triggered from WCS, you can create a package and send back a set of information. Perhaps you have an RFID reader and you need that data to send up to the MES, so you can process that data, get an RFID, get a material data from the container, and then pass that to your MES. We When you make changes at the ECS level, it is synchronized automatically with WCS if you have a workflow that is using an ECS rule chain. As you change the rule chain, it will update and synchronize the WCS. There's no manual work that needs to be done for that. It's all handled automatically by the system. The rule chain library is, again, it's a flowchart type of block diagram that you can use to um, tie nodes together. Each node represents some type of functionality, whether it's like reading data, writing data, triggering an event, waiting on an event. Um, these nodes can be tied together, and based on if the action that occurs in that node is successful, it can continue on the rule chain. If there's an exception or some kind of problem that occurs, you can trigger an exception within the system that maybe notifies the workflow that we have an error down at the ECS chain level. They are very flexible. You can build them up. You can use them to write attributes out of the system and say into a database, and you can use the ECS system to monitor the status of a device. It'll display the connection of a device along with the process, the progress of the execution. If there is an exception, it can provide manual or automatic responses to that exception. You can, for instance, have it retry this rule chain, retry a node in the rule chain. You can cancel the rule chain and send an exception to the workflow, these kind of things. And it allows you to see real-time monitoring data of the device it's talking to. So that's a high level of what KMReS, the subsystems. What I want to do now is just again show you. I have the system running in a VM currently. This is KMReS. I have it in the map monitor currently. So this is the application itself. It is a web application. It's running on this is running on a Windows box. We also run on Linux. In this, you have different features of this. So you have their map being able to create your maps, being able to create your warehouse, segregate your maps into warehouses, map floors. When the map floor, you're able to, at this point, you can create your graphs. You can create areas that are forbidden areas. You can create areas that are have only certain platforms are able to enter that area. You can create um, um, you can create your district where you can assign specific platforms to that district. And for this item, if you look at our graph, oops, we have a SLAM map here. It's a simple SLAM map. I've created a simple graph on this map. Um, the vehicle is constrained to the graph. Nodes are locations on the graph. Edges are where the vehicle will move between one node and the next. You're able to assign different attributes and configure different parameters on the edges, on the node. You can create events, like I said earlier, pre-events, post-events, departure events on nodes and on edges. Um, you're able to create specialized nodes in the graph. These specialized nodes can represent things like a rest position, a parking position. It can you can create rack positions. You can create a charging station. In this particular graph, excuse me, in this particular graph, I've configured it to have a parking or rest node. I've configured 2 container nodes, and I've configured a charging node. In order to edit your map and add locations, you can add new nodes. If you need to add a node, you can add new nodes to your map and then tie those nodes together. And I'm doing this rough so I can represent the editing tools next. So I have a simple branch that I've added to my graph. And again, I want to organize this, so I'm going to edit these nodes. What I want to do is I want to organize this so that we're kind of, excuse me, I'm going to organize this so that it matches the rest. I'm able to delete nodes as I've added them. I added an extraneous node there. So I can select multiple elements in the graph, and then I can organize them and save that organization. I can, oops, I'm just kind of cleaning the map up here at the nodes I added. And I guess I'll do one more. I'll create these and level these out. And I've clicked a couple spots on the map when I was doing this that added extra nodes. So I'm going to remove those by deleting those. So I've added another branch to my my graph. If I want to make this a special case node, I can right click on the node itself and I can say edit. And this is where I would set the parameters for that node in this first screen. And then there's a function screen where I can actually change what type of node it is. So we're constantly adding new functionality to each node. These are the list of what we have right now. I'm going to make this a rack node, and I'm going to use a model for that rack. I have a pre-created model called a 1 meter box, and I'm going to save that. And when I do that, you see that that node gets changed to a container node. That's your editing. That's kind of an overview, a quick overview of the editing. I'm going to save this map and I'm going to exit out and add a robot. So I'm going to go over here to MR info and I'm going to come over here and add a robot, add a vehicle to my map. I've got a vehicle pre-created. It is a simulated robot. It's not an actual physical robot. I'm going to add this to my map and it's going to add it. I can tell it where I want it to add, but it's going to add to node 1, for instance. When I confirm that, if I come back and look at my map, you can see that I have to apologize. I messed up. I have to enable my map before I can add my robot to it. So I'm going to add the robot now, enter it. And then I'm going to go look at my map. You can see I now have a vehicle, a simulated vehicle attached to the graph. It's sitting on the rest node. I can manually command this vehicle, make it a little bigger for everybody. I can manually command this vehicle. I could tell the robot to just do a move action. I want to move it to some location. Maybe I'll move it down here. This will create a mission for the robot, and this robot would then be commanded to move down there. I have a rest node, that parking node that it came from, already set up. So after the mission is done executing, after a few seconds of inactivity, no new missions have arrived to the robot to tell it to do something else. At that point where this time frame expires, the robot will be instructed to go back to the park position. Park positions can be configured to be, if you're running a mixed fleet, it can be, this park position can be just for the 1500. You could have another park position that's only for the 600. You could have a park position that's mixed. It can be 1500 or 600. You have that kind of flexibility. I can tell the robot to charge. The simulated robot, when you look at its, let me cancel this real quick. The simulated robot, when you look at its battery levels, currently 89%. A simulated robot will use the battery just like a real robot. So as you're running, the battery level will go down. So you can actually command this robot to go to charge, and you can select your robot, and then you can tell how much you want to charge it to. So if I'm at 89, let's say I charge it to 90, and I say okay, the vehicle will receive a mission to tell it to go charge. It'll drive to the charger just like this is the same function, even though it's a simulated robot, it's the same functionality as a real robot. The robot will drive over there, it'll localize to the charger, and then it will spin itself around and dock to the charger automatically and start charging. As this is a simulated robot, the charge level goes down, but it doesn't go up, unfortunately. So in this case, it came back and it finishes charging. You can see the battery level. It put it to 90. And then after a certain amount of time, when the robot has no further missions and a certain amount of time of inactivity, it'll go back to the park position, right? Another manual command that I can do is, if down here at this node, you can see I have a container on this node. I could tell the robot that the MR, that I want it to carry this container and put it on this rack. And I can manually create a mission to perform that action. So in this case, the simulated robot's going to drive to the container. It is going to then take that container and carry it to the other rack and drop it off. You'll notice that the AMR rotated underneath it, but the container load did not. I didn't configure it to move with the robot. I was putting together a quick and easy simulation. So in this case, the robot is rotating under the rack. That's not how you would do it in the real life. It would carry it out the way it came. Um, but this is representing what you can do with the robot on the graph. So this is all manual commands. These manual this manual functionality is what you would pull together for a workflow. And so let's go take a look at a workflow real quick. So in your workflow config, you can have a list of workflows. I'm going to add a quick workflow just to show. I'm going to say, okay, I'm going to work on a certain map. I'm going to name this workflow something really exciting, workflow 3. It's going to be a load. I'm just going to do a load. And I'm going to put a virtual button on there. And so for this workflow, it'll create a workflow. I'm now in the editing screen. It's going to be a simple workflow. I'm just going to have this robot, a robot. I could tell it a specific robot. I can tell it a specific family, or I can make it agnostic, and it can be any platform that you want. I'm going to create a map node, and I'm going to tie I'm going to try to tie, I guess. Here we go. I'm going to tie this node to that, and on this node, I'm going to give it a name, move to 1, and I'm going to tell it, okay, where am I going to go on the map? I'm going to select a node on the map. I got to tell it what map I want to select. And I said move to node 1, so let's go over here and select node 1 right there. So I'm going to select node 1. And then I'm going to create another map node. And for this map node, I'm going to say move to, let's say 6. And I'm going to go select that in the map. So I'm move from 1 to 6. I need to tie these two together. And then I need to tie this to the end. And now I need to save this. Let's eliminate this for now. I'm not going to put a button. So I saved the workflow. It's now in my list of workflows. It was workflow 3. I can trigger that workflow here, for instance, to test it. If a mission will be created, when that mission is created, it'll get the robot will execute the workflow. And then after a certain amount of time of no inactivity, it'll go back to its park position. So from a high level, that was a workflow. You would build this workflow out to add more functionality. For instance, if there was a door that I was going to pass to, I would have to call an ECS chain from within the workflow and then wait for that workflow to return to say that the door is open before I proceed on in the workflow. That would be configured in there. Let's take a quick look at ECS, a rule chain. So for rule chains, I'm going to add a rule chain. Let's say open door. Let's say we're going to do door. So we have some default rule chains already set up, button boxes, chargers, lifts on. So I'm going to select the default one, the open door. I'm going to create that. And there are some templates that are already here that you can use This is a Modbus template to talk to a door. When I do that, it gives me a rule chain that is pre-configured, and then you can go into the each item and you can set up the attributes and the options and the parameters for what you're doing. For instance, control open door. If, for instance, we're talking to a Modbus system, I would go in and set up the Modbus information and where we're connecting. I'm not connected. This is a simulation. This isn't a VM. I'm not connected to any real world equipment, so I can't really demonstrate beyond this. But this will give you an idea of what's there. And if I save this and I come back out, you can see out if there if I have equipment connected, it'll show up in this list, and I can monitor that equipment from this list. But unfortunately, like I said, I don't have equipment here. And then from my workflow, I can configure a node to when as I reach a node, I can call that rule chain from the node to interact with that equipment. And containers, the last thing I'm going to, well, I'll also show you the job board here. So the job board will show you any active missions that are running and give you their status, whether there's any issue or it's working correctly. And then finally, container models. This is where you can configure the containers your system is going to work with. You would give it the size and you could give it data that represents that container. KMReS and the vehicles are set up with a camera that can read QR codes that are put onto a container so we can pull information off your physical container and then take that information and send it up to your MES system. So this is where you would configure the physical dimensions of your container. And then I think at this point, I'm going to wrap up this overview. Like I said, this was a high level overview. Just trying to hit some of the bullet points. If you need more information or you have more questions, please feel free to reach out to your salesperson. If you don't have a salesperson, reach out directly to KUKA through the Focus Center or through application engineer if you have contact there. We can get in touch. We can do a more in-depth demo with you. We can do on-site demo with our machines, set up a system for you, have you test it. We can bring you in and show you on-site our systems. We have training for end customers and training for integrators. And with that, I'm going to open it up if there are any questions, and we'll move to get you back to your work days. Okay. Okay, so how accurate do you have to be when placing QR codes on the work floor? So that's a good question. The machines without a QR code are plus or minus 10 millimeters of accuracy, right? The QR code, the machine will be plus or minus 5 millimeters to the QR code. So depending on how accurate you want it to be to your location, that's how accurate the QR code needs to be on your floor. So you're going to be the QR code plus or minus 5 millimeters. You're welcome. I know this is a high and fast and dirty, hard to get an idea what your questions are, but again, if you have any further questions down the road, don't feel free to call us. Please feel free to call us, and we'll do our best to reach out to you and set up and talk to you about your applications and tell you about your questions. And with that, that ends my presentation.
Hey, Joe, I think there was two more questions.
Oh,
If
were
you'd like,
there?
I think you would like to answer these. They would just like to know, is the KMR Quantec a different platform or is it the same?
KMR Quantec is a different platform. It runs on the OmniMove platform, which is a omnidirection platform that's special built. It's basically they're special built. These platforms that we're working with here, the 1500 and the 600, are differential drives. They'll move in, they'll turn in place, they move forward and back. The 3000, which is coming here early this year, is a traversal drive. It will move sideways and diagonally. The OmniMove platform is the Mercom wheel platform. It moves in any direction also. And for the KMR Quantec, they mount the Quantec on top of the OmniMove, and that's how that platform is put together. Also, currently the OmniMove, the KMR OmniMoves, the KMR Quantecs, the big guys, they are working on a different platform of software. They're not using KMR at this time. They're using the existing navigation solution.
There's another question. It says, are there applications currently going into elevators?
In So I see another question: what countries these AMRs manufactured in? So I'll answer both questions. AMRs are manufactured in China, and they are going into elevators in applications in China. We don't have any in North America yet, but in China they are doing applications into elevators.
Where is the KMR Quantec manufactured?
KMR Quantec is manufactured in Germany.
Alrighty, thank you. Then there was a question from Luke. Can we have this presentation? This presentation will be live. It will be live on YouTube as well as you can find it on our website. The live recording will be live in about a week or two, and that is for all of our past webinars as well. How does the vehicle respond to an obstacle in its path, Joe?
So the vehicle has the ability to you have the ability on an edge to determine whether the vehicle uses obstacle avoidance or not. Meaning, if there were a pallet, for instance, that was sitting in front of the robot, and you have configured the edge such that obstacle avoidance is enabled, the vehicle will, the RCS, the robot control system, will attempt to do a obstacle avoidance. It'll based on the location of the obstacle to the vehicle, it will try to find a path around first without moving so that it doesn't start a motion and can't finish the motion. But if it starts a motion and it can't finish, then it'll stop and it'll be in an error state at that point. But if everything is correct and you have enough space that it can get around the obstacle, the vehicle will automatically go around the obstacle, come back to the edge, and then continue on the path.
Okay. Is there a solution that's available to safely bring an AMR inside a robotic cell with light curtains to do a pallet refill, as an example?
Uh, yeah, yes, there is. Obviously we need more details of what the system has, but what you can do, I was just talking with a customer this morning. The robot comes up to the cell. The ECS, the equipment control system, will interface to the light curtain controller and tell it is going to pass through the light curtain, so to disable the light curtain. The vehicle will move through the light curtain and in front of the rack. It'll find its location reference to the rack. It'll then shrink its safety zones and travel under the rack and you know, depending on what you're doing, whether it's conveyor or lift, or it'll lift the rack, the pallet, whatever's on the rack, and then it'll drive out, interface with the light curtain again on the way out, and then exit the cell and do a thing. We have applications. There are applications out there that do this, yes.
And then Brian, in the question box, he said you should mention that these are Section 889 certified.
These are 889 certified. Thank you, Brian.
I think that is it for questions as far as it goes, though.
All right. Thank you for your time. I hope you all have a great day. Talk to you again.
Industrial intelligence.